Hi everyone, thanks for checking out the video. Today we're going to be looking at adding positive and negative numbers and trying to predict by looking at the particular problem whether the sum will be positive, negative, or zero. We've been using integer chips and number lines. Eventually we'd like to get to the point where we can do this stuff fluently without those tools, but right now we're still working on developing that understanding. So let's take a look at the problem. Use integer chips to model the problem. So here we have negative 5 plus 3. So we have 1, 2, 3, 4, 5 negatives, and 3 positives. 1, 2, 3. And from earlier discussions, we said whenever you have a positive and a negative value, they come together and make a zero pair and kind of cancel each other out. So here's a zero pair here, gone. Zero pair here, gone. Zero pair here, gone. And what's left over? Negative 2. So our answer will be negative 2, since there were 2 negatives left over after the zero pairs. Okay, here we have negative 4 plus negative 9. So we have 1, 2, 3, 4 negatives, and then we have 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do we have any zero pairs? No, we don't. So we can't zero anything out. All we're left over is with a whole bunch of negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 negatives. Our answer will be negative 13. So here we have a situation. Jessica has 8 video games and Melissa has 5 video games. How can you express this situation with integer chips? Well, Jessica has 8 games. That's what she has. 2, 3, 4, 5, 6, 7, 8. Melissa has 5. 1, 2, 3, 4, 5. How much do they have in all? Well, she's got 8 games and she's got 5. So together that makes 13, since all the colors are the same, no zero pairs. Just like in our do now, there were no zero pairs here, it stayed. No zero pairs here, so we had 13 positives. Let's keep that in mind. We're going to be using a word this year that sounds like a really fancy word, but algorithm is just a process of doing something, or a plan, or a series of steps for doing a computation. And computation is a fancy word for calculation or just doing the math for something. And a commutative property of addition, when maybe your parents commute to work every day, they go to work and then come back. So the word commute is to move around, and in addition it doesn't matter. So if I was to say 3 plus 2 is equal to 2 plus 3. If I was to solve the left side, I'd get 5 on this side, and if I was to solve the right side, I'd also get 5, right? Because 2 plus 3 is 5, 3 plus 2 is 5, and 2 plus 3 is 5 also, same thing. So that just shows the commutative property of addition. You can move things around, get the same thing. Desert Station, the temperature at sunrise was 10 degrees Celsius. It rose 25 degrees by midday. What was the midday temperature? In what 2 ways could we model this? Well, we have 2 options. We could use integer chips, right, which we've been using a lot. It was 10 degrees, so we could 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it rose, which is a version of the word rise, which means go up or increase, right? 25 degrees, so then we could haul out 25, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 5. And this all together represents the new temperature, which 10 and 25 together would make 35. Or we could use a number line. We could start at 10 degrees, and we could rise 25. So is rising to the left or is rising to the right on a number line when we're dealing with rising a positive value? Well, it's going to go to the right, 25. So the way our number line is arranged is each number goes by, each skip or hop or whatever you want to say is 5 units. So this is like going 5, 10, 15, 20, 25. Where do we wind up? We wind up at positive 35, which is what we found out up here with the integer chips. Same deal. All right. So there's this very important question, and really this is the root of today's lesson. If I give you a problem, how can you look at the problem to tell if the sum will be positive, if the sum will be negative, or if the sum will be 0? That's what we're going to discover. So I want you to think about that now. You can put this video on pause, think about it, and then come up with an answer, and then we'll get to this in a moment. So at this point, we divided everyone into 2 groups. Group 1 worked on these problems, Group 2 worked on these problems, and we got some answers. All right? Positive 2 plus positive 8. You guys have been doing that for years and years. You know that that's 10. If you used integer chips or a number line, if you used a number line, you started at negative 2, and you added negative 8, which really means move to the left on the number line, and you should have wound up at negative 10. Likewise, you could have used integer chips, 2 red chips, 8 red chips, together makes 10 red chips. Okay, same deal here. 8 and 12, you guys all know, is 20. Please excuse that noise. There's just some water dripping on the AC unit outside. Negative 8 plus negative 12, same thing. 8 red chips, 12 red chips. That gives us 20 red chips. Maybe you start to see a pattern. Maybe you're starting to see a pattern with what's going on here. We'll get to that in a second. Here, we have 2 black chips and 8 red chips. So what's going on here? Well, we have more red chips than black chips, so we're going to make 0 pairs, and we should get negative 6. In this particular case, we had more red chips than black chips, so we would have gotten positive 6 if we were using chips. Or you could have started at negative 2 on the number line and then moved 8 units to the right, and that would have wound up at positive 6. You know what, let me give a visual just so maybe that's a little easier to see. Here's our number line, or maybe I'll do it down here. If we started at negative 2, 8 units to the right would have put us at positive 6. Okay, how about if we started at positive 8 and then we're adding negative 12, which means move to the left. So if we started here and we went 12 units to the left, well, 8 units would bring us back to 0, and another 4 would make, so that would make 12 total hops to put us at negative 4. So this should be negative 4. And if we did it the other way around, starting at negative 8 here and went 12 units to the right, we'd wind up at positive 4. Or you can think of integer chips. We'd have more positives and negatives, so we'd wind up, whoops, typo, at positive 4. Now, do you notice any? Forget about the answers. Forget about the answers now. Forget about the answers. Just look at the problems themselves here. What do these problems have in common? Well, you might be thinking that the signs are the same for each problem. Like here, I'm adding a positive and a positive. They're the same signs, right? Here, I'm adding a negative and a negative. They're the same signs. Positive, positive, negative, negative. And you might start to notice something about what happens with the answer. Okay, here, I'm adding a positive and a negative, and we are winding up with a negative. I wonder why. Here I'm adding a negative and a positive, positive, negative, negative, positive. So the signs are different in these problems, and you should start to notice something. In these problems, if you were adding 2 positives, your answer was positive. If you were adding 2 negatives, your answer was negative. Right? Because there are no 0 pairs to happen here. So it's like I owe someone $2 and I owe someone $8. Altogether, I owe $10. Same thing with these other problems. Group 2, however, is a bit different. One of them's negative, the other one's positive. So thinking back to the other day when we did Tate and the mowing of the lawn problem and he had to pay his sister back, he owed her $6, but he only paid her back $4. He still owed her money, right? Same idea here. I owe someone $8, I pay them back $2, I still owe them $6. There were more negatives than positives here, so my sum needs to be negative. There were more positives than my negative, so my sum is positive. It's like I owe someone $2, but then I get $8. Well, I pay them back the 2, and then I have 6 left over, positive 6, right? And the same holds true for these other problems. So this brings us to the addition algorithm. When adding integers, if the signs are the same, add, I'm going to just say the absolute values, and keep the sign, okay? So if the signs are the same, add them together, add the absolute values, and keep the sign or whatever they are. So 2 positives, add them together, keep them positive. 2 negatives, add them together, keep the negative sign. Group 2, so that was all group 1 type stuff. Group 2, it was different. When adding integers, if the signs are different, find the difference of the absolute values and keep the sign of the number that has the greater absolute value. So again, if there are more negatives than positives, your answer is going to be negative. If there are more positives than negatives, your answer is going to be positive. So that brings us back to this question: how can we predict whether the sum will be positive? If we're adding 2 positive numbers, it's going to be positive. Or if we're adding a positive and a negative, if there are more positives, then the answer is going to be positive. We can predict if it's going to be 0. If we're adding 2 negatives, then the answer's got to be negative. Or if we're adding 2 negatives and there are more negatives, then the answer is going to be negative. And 0, if the absolute values are the same, but one's a positive, one's a negative, then you're going to get a 0. We have vortex here, right? 5 plus negative 7, is it going to be positive or a negative sum? Well, there are more negatives, right? How about this one? Positive. Well, the signs are different, so I need to keep the sign of the one with the greater absolute value. One's positive, one's negative. More negatives, it's got to be a negative sum. How about this one? I'm adding 2 numbers that are both negative. It's like I owe someone $3, I owe them $7. Altogether I owe, I'm sorry, 03, 04, altogether I owe 7, negative. 3 plus 4. You've been doing that forever. I'm not going to insult you. Right? How about this one? More positives than negatives. Your sum needs to be a positive value. Where should this go? Yes, you guessed it. Positive. Different signs. Keep the one with the greater absolute value. There are more negatives than positives. Ooh, that's a big number. Does it matter? No. There are more negatives than positives. Think to yourself, where should this go? Where should this one go? Where should this one go? How about this one? This one? 45. Oh, come on. We know that one, right? Last but not least. Okay, hope that helped with you guys. Make sure to do your homework tonight, ask questions in class tomorrow, and have a nice day. Thanks for watching.